All right, so vertical asymptotes.
I don't do that.
I don't have that. No, I don't have that.
All
right. So what's a vertical asymptote?
4.
I don't know. Just 4.
Wait, is it horizontal on the bottom?
No, vertical is the zeros of the numerator. Yeah.
It's 3.
Oh, that's me. I didn't know how to work.
So zeros of the denominator that are not also zeros of the numerator.
Just find H and A. You did.
I didn't put those there.
Isn't that what we read?
All right, horizontal asymptote. So this is where we look at the powers. We look at if there's a bigger power on top, bottom, or the same.
Is it not?
And well, it's the bottom, right? The bottom's bigger because this is the first power. This is like an x to the 0 power almost. Because there's none. So if it's bigger on the bottom, it's at y equals 0.
Well, it's about also 0 because you can't. It's not that way.
And there's no holes. We didn't have anything to cancel, so I'm just gonna write no holes.
How would you find holes if there was one?
We'll see on the next one. Okay, so what we're gonna do is then plot this information. So we're gonna plot the x-intercept, which there is none. Y-intercept is at -4/3. So I'm gonna put a dot there. It's just below -1. We've got a vertical asymptote at x equals 3. That's going to be just a dotted vertical line on 3. A horizontal asymptote at y equals 0. So it's going to go this way at 0. So that's all the information we know. We're then going to pull it up on Desmos. It's 4.
Mr. Davis, can you retype by? Can you go pretty far?
I can go decent, like the first 10 digits. 3.141592655 8979
That's our question right there.
All right, so this is the graph of what we just did.
So what do we have to go on?
So-
That sounds stupid, but what's the dot?
So right here,
The dot that you drew.
this is -4/3.
Yeah.
Is how we put on. So that's the y-intercept right here.
So
And
is
you'll
that the
see,
line?
you'll see on the Desmos graph, that's where it crosses, the y-intercept. There was no x-intercept, so we didn't have it cross here. But you can see that there is definitely a vertical asymptote here, and there's a vertical asymptote here.
I've run this whole thing before. It's just not coming back.
You learned this before?
Yeah.
Okay.
Because it's like those are the new x and y axis, right?
Say that again?
The dotted lines are the new x and y axis.
Kind of, yeah. I like that, yeah. You can think of it that way. Yeah, and then we're just going to draw on the sketch of what we have on Desmos. Just confirm that it's the same. So again, the only spot that we really have to mark is just the 0, -4/3. That's the y-intercept. And then, but you can see there definitely would be a vertical asymptote at 3 and a horizontal asymptote at 0. So we're good. That's our sketch.
That's pretty cool.
Yeah, it's not that hard. All right, now the next one, we do have to do some factoring with that one. So we're going to start with the top because that should be the part that you should already know how to factor. So take a second, don't say it out loud, and factor that really quick.
Just the numerator.
Yeah, just the numerator for right now. What multiplies to give you 12 and adds to give you 7. Yeah, this one, each one you should be able to get.
Oh, dude, this is gonna be hard. Oh, this is not hard at all.
If you can't get it, you have to go back to algebra 1.
Huh. You don't like Mr. Davis? I didn't say it.
Yeah.
Mr. Davis is probably one of the better.
Can I tell you what? I just learned how to do this on Friday, by the way.
That's not true.
With my own brain.
3 and 4, is that what you got?
Yeah.
Yeah, 3 and
And
4.
that's like, I was going to tell you the answer, but you were
There
so
you go.
smart, you already answered it. Doesn't matter what
Wait,
you
wait,
answer,
wait. I'm stupid.
I put 5 and 2.
All right, Josh, do you know how to factor the bottom?
Yeah,
What do you do it?
I got the answer. I don't know how to really explain it, but I did it.
Wait,
Well,
don't you?
all right, how about you try to explain it?
Oh, the bottom.
Yeah.
I'll do one at the top. Alrighty.
All right, well, let's do the bottom now.
Let me do the bottom first.
You divide
I'll
by
tell you.
two.
Yeah, so you definitely don't want to deal with a number in front of there. All the ones that you're going to have that have a number in front.
Oh, I know how to do
Negative,
this.
isn't it?
Divide all by 2. What's
Negative twos.
Yeah, so you can't just ignore it. You're going to pull it out. You're going to put it out here like this. And actually, let's write it below here first. So we're going to pull on the -2, and then we're going to write what's left over. So we would have an x squared. Yeah, this is plus x and a -6.
Wait, why is it plus X?
That's a good
Because they're
question.
taking the two out.
So we took out the 2
Oh, it's
and
a
the
negative
minus
two,
sign.
alright.
So then we have a. Yeah. And you can always check by distributing. So if you distribute this back in, you would get that original thing. So now we're going to take this and we're going to factor it. So what does that factor into?
Negative 2, 3.
Positive 3 is
Good. Positive 3 minus 2. And then what you'll see is we have an x plus 3 on the top and the bottom. I'm gonna draw a line through it, but we're still gonna kind of use it on, on a couple things. But
Wait,
I thought you could hit if you cross them out.
wait, I
well,
thought you.
you'll see. Yeah, it's gonna be a hole because they're canceling. So this is gonna be a hole
But doesn't.
because it's gonna be a 0 of both the numerator and the denominator.
So I thought you only cross them out for the opposite.
No, if they're the same, you're gonna cross them out. If they were opposite sides and equal sign, then it would be the case. But yeah, they're the same.
those
They're
are
just like
factors.
1 over 1. Same thing over itself. Just 1.
So are the 4 and the 2?
Well, we have a bunch of different things. Yeah. All right, so let's do the domain. So the domain is all the x values, so we have to think what makes the denominator 0. Even though we canceled this out, I didn't completely erase it because this still would make the denominator 0, -3 would. So we still want to put that in the domain where it can't be. It's just here, this would make it 0 over 0. So -3 still gives us 0 in the denominator. So we're going to say all x's such that x cannot equal. This would be -3 and positive 2. This -2 doesn't matter because it doesn't have an x with it.
Where's the bottom?
Where did you get the 2 from?
So from this one, if you set the bottom equal to 0, you saw that would be 2.
So the main is all only the bottom thing, not the whole.
The domain is all numbers except these two, because these two make the denominator 0.
Okay, so the original after that's top.
Right, because you're allowed to have 0 in the numerator. So then we'll look at the x-intercept. Now this is where you want to know where the top is 0.
Okay,
The x-intercepts.
so
So the question is, we know -4 is a answer, right? What about -3? Is that also an x-intercept? Yeah, it's not because there's a hole there. So if it's a hole, then it can't be an intercept, right? If this didn't get crossed out, then we would say yes, it is an intercept. But this one's, we know there's a hole there. So we will hole in the graph. So just this one.
what would it look like on the graph? A hole.
I'll show you when we graph it. Just gonna get open.
That's what I was thinking.
Alright, y-intercepts, this is where we plug in 0 for all the x's. So this, you just basically ignore anything that has an x. This is 0, this is 0, this is 0, this is 0. So all you have left is this 12 over 12. So y equals 12 over 12.
This is really confusing. This is really confusing. Because because you factor it, but then you barely even use the factors.
Well,
We
we
just
still
it
use
for
them.
the main thing.
We used it, yeah, for both of these so far. And we're going to use it also for third class. And the whole. Well, for the y, you still could. It's just easier to use it this one because if you did it for this one, you would plug in zeros. You would have 0 plus 3 times 0 plus 4 over -2 times 0 plus 3, 0 minus 2. And then you'd have to like solve all that. You'd still get 12 over 12. But it's just easier to look at this form of it.
Okay.
These are just different ways of writing the same equation.
Okay.
So then vertical asymptotes, that's zeros at the denominator, that are not also zeros in the numerators. So what's that? Yeah, positive 2. X equals 2. Because we got the denominator factored, x equals 2 and x equals -3, but -3 is canceled out with the top, so it's not a vertical asymptote. And so we could go ahead and also just say that there is a hole at x equals -3. Because it gets canceled out. So that's like what we were doing yesterday. You were finding the vertical asymptotes, and then you were just typing in the ones where it wasn't a zero book. But now we're gonna say the whole if it's a zero book.
And is the 2 the number x minus 2 in the bottom or the one in front?
This one.
Okay.
Because if you were to solve this, it would be x equals 2. Horizontal asymptote. So this one we're gonna look at the original. You don't really want to look at this, because remember how we had some like this yesterday, but then you actually had to find the biggest term, or you had to multiply out, find the biggest term. This already is multiplied out. We have both versions of the equation. So we'll look at this one, look at the highest powers. So,
One.
yeah, -1/2. Because you would take the ratio leading coefficient.
I thought you used the paper.
Well, if they're the same powers, you take the ratio of the numbers in front of them. So this is a 1, that's -2. Alright, so that's all our information. Now let's plot these things. X-intercept is -4, so we're going to put a dot there. Y-intercept is 1. Vertical asymptote at 2. Horizontal at -1/2. The whole, we can't really graph right yet, but I'll show you how we're going to graph that in a second. We know there's going to be a hole in the graph at -3. We just maybe don't know exactly where it is. You can probably guess it's going to be about right here. But we don't know exactly where it's going to be. You can put it there if you want, but I'll show you that in a second. So then let's go ahead and pull up the Desmos graph. There we got it. So that's what it looks like. You can see it crosses at 1, and then here at -4. Oh, is it? Yeah, 1 and -4 is where it crosses. Now you don't see the hole though. There's supposed to be a hole at 3, right? You don't see it on this graph. Why can't you see a hole there? You know? There is a hole there.
Because
It's imaginary.
it can get infinitely close to it. And
Yeah, you can get like infinitely close to this thing. It's defined just after 3. So if I go to like 3.000 whatever.
It says undefined. I saw.
Right. Yeah, right at 3. It's just like there's so many close numbers to it that a computer just doesn't have like enough pixels to even like show you every infinite number close to that -3. So if you do put your finger on it though, it does say undefined. And actually you can't see it very well, but it does turn to like an open hole there. Can you guys see it?
yeah, I see it.
Touch it, but it turns to an open
Oh,
hole
yeah.
from a closed hole. Kind of see it. So that's why we have the little dot there, the open one right there, and then you just complete it with the rest of it. Just leave a little hole there.
This is probably the hardest one we've done.
I agree.
It's not my why, let's get rid of it.
If you just take it step by step and just like look at the directions of each one, I think you'll realize it's not actually that bad.
That's confusing. No, once I start to.
But the rest of the graph don't have to be perfect, like that other one.
Yeah, it's just a
Nothing about
sketch. Yeah, it's just a sketch. You're just
Yeah,
getting
just
the general shape of what it's supposed to look like. We just know that it goes like that. But there's no specific points you need to watch. All right, so you guys are gonna do the next two. This one is very similar to the first one, so you follow it almost the same way. This one is similar to this one as well.
Is those two our homework?
Yeah, then you've got the rest of the class to work on it. This is going to be a greatest common factor. Not- This is going to be a GCF. With your GCF on here, you also want to pull out a negative. So you're going to factor this with the greatest common factor. Pull out a negative as well when you do that one because you don't want a negative with the x left over.
So
Pull out
what
a-
are you saying? The greatest common factor is going to be a negative?
and something else.
What?
What would you pull out of here?
A
Like to help.
-3.
Yeah, -3. So then it's then I want you to finish the rest.
-3 decimals. I don't do it top.
And that's like the top factor thing.
That'd be the factor form at the top, yeah.
And then the bottom.
The bottom factors as well. There'll be one that cancels just like the one above it.
Wait.